Welcome to the Greater Atlanta Metastatic Breast Cancer Conference. My name is Katie Stone. I'm the CEO of Susan G. Komen Greater Atlanta, and I'm so happy to be here with all of you today. This is a first-of-its-kind event in Atlanta, and it has been a labor of love that has taken a whole group of people to put together, and I hope it's a beautiful day for you. I cannot wait to join you in learning more about metastatic breast cancer from our distinguished panelists and speakers, and then I know we have an awful lot to learn from each of you too. But first, a little housekeeping. We are live streaming this event today through our Komen Atlanta Facebook page, so if you had friends or loved ones who wanted to join you but were not able to, send them a little text and let them know that they can watch it live all day. Also, once the event is over, we'll break up the day into smaller videos so that you can go back and watch any content again or share it with others. I'm sure you're going to learn some things that you're going to want to revisit. We're happy to provide everyone with complimentary parking validation. Otherwise, it's a little expensive, so if you haven't picked up your parking and take a right, you'll find them down on your right-hand side. The resource fair, which I think most of you or many of you have already enjoyed, will be available all day. I went and walked through the tables myself. We have a lot of amazing community partners there with great resources, and they're just lovely people who are interested to learn more about you and what they can do to support you. So please enjoy the resource fair. And then closer to the end of the day, we're going to be providing you with a survey. Please, please take the time to fill the survey out. It is so important to us that we hear your voices and that we know what it is that you want to hear. Is there something you didn't hear that you wanted to hear? Is there something you didn't like? Is there something you really do a better service? And then I'd like to thank some very important people before we get started. Putting this event together, as I mentioned, truly was a labor of love. It started with an idea from our very talented Komen Atlanta staff, and it came to life thanks to our amazing advisory committee, which is made up of friends who worked with us on everything from content to marketing to logistics. And I'd really like to ask if the Komen Atlanta staff and advisory committee could please stand and be acknowledged. So appreciative of their investments in making this day possible. Northside Hospital Cancer Institute, Eli Lilly and Company, AZI, Cancer Treatment Centers of America, Amgen, Celgene, AstraZeneca, Genentech, Pfizer, Myriad, and Sacred Journey Hospice. Thank you so much to our sponsors. And it really goes all the way back to our origins. Susan G. Komen lost her life to metastatic breast cancer in 1980. And before she died, she challenged her sister, Nancy Brinker, to do everything she could to end breast cancer forever. And Nancy made that promise to her sister and started the Susan G. Komen organization, which is now the largest breast cancer organization in the world. It's amazing what one promise from a sister to another sister can do. Since Komen's founding, breast cancer mortality rates have decreased by 34%, but there is obviously still more work to be done. So Komen has set a bold goal to reduce breast cancer deaths in the United States by 50% by 2026. It is indeed a bold goal, but we have plans to make it happen. And I want to talk to you a little bit about what those plans are, and hopefully you'll be motivated to help us. So here's what we're going to do. When you think about Komen's work, we are divided into sort of two houses. One is the research investment of our work, and then the other is what we're doing here in our local community. And I'd like to start by talking briefly about what we're doing in our local community. In order to reach our bold goal to reduce mortality, we are going to be focused on achieving health equity in Atlanta for our African American sisters, who are 45% more likely to lose their lives to breast cancer than their Caucasian counterparts. 45%. That is unacceptable. We're not going to stand for that. And so what we're going to do is continue our efforts in Atlanta with a special focus on the African American community. We're going to increase education. We're going to increase access to services. And then we're also going to be providing some enhanced patient navigation. And we're very excited about this work. I would love to talk with any of you about it in more depth. But today I really want to focus on the research side of how we're going to reach the bold goal. And we're going to reach the bold goal by doubling down our research investments on metastatic breast cancer. We've been funding metastatic breast cancer research since the very beginning. And I'm very proud to say that our last research portfolio, so last year we issued $26 million in grants. That's just one piece. There are many other dollars already at work in the research arena, but just last year alone, 60% of Komen's research investment was focused on metastatic breast cancer. We're very proud of that, but I think that you will see in the next week or month when the new research portfolio is announced that you will see probably 80–90% of our investments focused on metastatic breast cancer. We are committed, and we're very proud of that work. We know stage 4 needs more. We know it, and we're committed to doing more. And everyone in this room and all of the partners, everyone who made today possible knows it, and we're committed. We're in it with you. In Atlanta, that's going to mean more conferences like this one. We need to bring the city together. It means more events like our recent Bubbles and Bling cocktail party, where all the dollars raised that night were focused specifically on metastatic breast cancer research. It means creating more awareness and providing more support for those living with the disease. So together we can do more, we can be more, we can love more. And we thank you for being with us today to make it all happen. And speaking of loving more, it is my pleasure to now introduce you to your next speaker, my friend, Miss Liz McLaughlin. Liz is the founder. Liz is the founder and president of Results Executive Search, which specializes in call center recruitment. She's had a storied career, which started after she graduated from Northwestern University in Boston, Massachusetts. You're going to hear her Boston accent. It's adorable. Her first job out of school was at an executive search firm in Boston, and very quickly she was named Rookie of the Year and thought she could go out and do it on her own. So she did. She started her own executive search firm that was very successful in Boston, where she specialized in the biotech arena. After 7 years doing that, she set her sights on working in corporate America and went on to work in human resources at Fortune 500 companies, including Progressive Insurance, Boeing, and Comcast. Not too shabby, right? At Progressive, she started and headed up the Community Involvement Program and served on the board of several organizations. It was also while at Progressive when she was diagnosed with breast cancer, stage 3. This was almost 10 years ago. Almost 8 years after her initial diagnosis, her breast cancer returned on her 60th birthday. Liz is now living with metastatic breast cancer, and she's here with us today to tell her story. Please welcome Liz.
Good morning. I am very excited to be with all of you today for the first annual Susan G. Komen Metastatic Breast Cancer Conference. I, like many of you in this room, am living with this horrific disease and have also been a caregiver to a cancer patient. I wanted to start with a quick shout out to Susan G. Komen Atlanta team, Julie, Katie, Ashley, Teru, and Alexis. 2 weeks ago today, they concluded a very successful second annual More Than Pink Walk. I was one of the 5,000 walkers and fundraisers who raised nearly $1 million, of which 25,000 will go directly to fighting the disease that we are gathered here today for. The remaining dollars will fund screening and diagnostic programs for low-income women here in Atlanta. Thank you, Komen Atlanta team. A month ago, I was sitting at the Antigua Airport Lounge traveling back from Dominica on business. I received a text from Susan G. Komen Atlanta that read, "I know you're traveling, but you are also proudly displayed on a billboard on Georgia 400. I was so excited, I immediately texted my caregiver with the news. With no hesitation, he responded, "What? For one of America's top 10 most wanted. 1 month from today, on June 18th, it will be 10 years that I first learned I had breast cancer. We moved to Atlanta on a Tuesday, and the following Saturday, I received a certified letter. Before I left Philly for good, I wanted to make sure I had all my medical appointments and tests. They were all done before I left, including my mammogram and my bone density test. As you know, moving from one state to another requires medical professionals and testing facilities and research to get the doctors you need. I did not have a support system here in Atlanta. I knew only one person in Georgia, and she is with me here today, Lisa. Lisa was nice enough to connect me with her doctors. It was stage 3 breast cancer. Soon after I had surgery, it had traveled to my lymph nodes. They removed my sentinel nodes and 13 lymph nodes. Then I started chemo treatments, followed by a second surgery, then radiation. I finished my treatment the following May of the following year in May. Towards the end of May of that year, I was returning from a business trip from California. I remember that I was so fortunate enough to have been upgraded to first class because I traveled so much for work. Typically, up front, the flight attendants have more time to chat with you. And one of the flight attendants came up to me and asked me why I was wearing compression sleeve and glove. I skirted the question. I really didn't want to answer it. When she left, the gentleman beside me said, "You wear the compression sleeve to prevent lymphedema, correct?" I nodded yes, and it turned out that he was a medical oncologist returning from a business conference. We talked much of the flight. As we were exiting the aircraft and saying our goodbyes, he said to me, "Do not be selfish." I looked at him with a huge question mark on my face, and he said to me, "You want to share your story with others. Those people need to know that they're not alone." As a result of that encounter, I have shared my story for several years, and that is why I'm here today, to share and receive our stories and our learnings and our hopes. 1 year after this encounter, during a routine scan, doctors saw a new growth on my inner rib cage. It was in a place that they could not conduct a needle biopsy, and I had my third surgery. They took a section of several ribs so they could examine the growth and then refused my ribs together. I was told that I would be hospitalized for a week. On the 6th day, I was so uncomfortable with all the tubes in my bodies and not getting any sleep that when the nurse came in the next morning, I asked, "May I just go home?" He said, "Absolutely not." After he left, I got out of bed, went to the bathroom, and made myself up. I worked on my hair and applied fresh makeup. When the surgeon came through making his rounds, he said, "Wow, you look great. I think we should get you out of here today." A short while later, the nurse came in, looked at me, and said, "Are you in sales? You just talked your doctor into getting you discharged today." Oh, after 8 years of being on tamoxifen, just when I was feeling like I had this cancer licked, I learned 21 months ago on my 60th birthday that the cancer had returned. It is in 6 areas of my body, and I'm on my 22nd round of chemo. Last July, I had radiation treatment on my neck and could not eat solid foods for 2 months. This is not the birthday gift anyone would want. A lot has changed for me during these past 10 years. One area of my life that has changed for the better is that I have many friends in Georgia today. Most of my dearest friends I met through Susan G. Komen. The first survivor I met is here with me today, Jane Radman. We have walked hundreds, perhaps thousands of miles together, and she is my mentor. Now on to the caregivers. I have a personal experience with this role. My dad was diagnosed with terminal cancer November 18th of 2000. For many years prior to this, he told us he never wanted to go into a nursing facility, but wanted to finish out his remaining years at home. While my 4 siblings wanted to have him move to a nursing home, I just could not agree and wanted to be with him and care for him at home. After all, Dad worked on the railroad, and he worked a second job as well. He worked 16 hours a day most of his life to put food on the table and send all 5 kids through college. I knew that caring for him in his own home was the very least that we should do for him. After some heated discussions with my brothers and sisters, I made the decision to leave my family, my friends, and my absolute dream job and move in with my parents in the home that we grew up in. It meant moving away from my home in Massachusetts to Rhode Island, which was 2 hours away. My dad slept on the hospital bed in the living room, and I slept next to him on the couch for 11 months. A couple of months passed, and my siblings became more supportive. They even gave me a Team Lead t-shirt, agreeing that mine was the right decision. I felt blessed that financially I could make that decision. I went to every radiation and every chemo treatment with my dad, experienced all of his nightmares. We had long and deep conversations over that period. He would often talk about being in combat in World War II and serving his country. Dad would also discuss coming home from his railroad job and dashing off to his second job as a night teller at the racetrack, and always wanting the best for his children. One night, Mom and I were holding one side of Dad up so he could go to the commode, and suddenly he was not moving. Dad was grimacing, uttering unrepeatable statements and pointing down to the floor. In our haste to help, neither of us had noticed that his pajama bottoms had fallen straight to the floor and tangled up around his ankles. We just burst out into laughter, all 3 of us. Caregivers, you are not always going to do it all perfectly, and that's totally okay. There are many times when I'd walk into a store like a CVS and come out empty-handed, not knowing what I had gone in to buy. Or Dad would ask me for something, and I would walk into the kitchen and forgot what he asked for. It was not old age, as it was 20 years ago, and I was about 40. And it was not chemo brain, because I had not been diagnosed as of yet. I guess you can call it caregivers' confusion. Dad died 11 months later with our priest and 20 family members by his side in that same living room. I stated before that I left my dream job, but being my dad's caregiver turned out to be my real dream job. I never regretted the decision I had made. It was the best decision I've ever made in my life. Caregiving is hard work. It is tough and it is stressful. Doing it is a sacrifice. We understand that, and it is why each of us love you even more. Now for the empowerment part. I call it my 3 B's. Be brave. When you are anxiously awaiting for the results of your latest scan to come back. Not too long ago, I heard Emily from Northside referring to this as scan anxiety. Shortly after I was told the cancer had come back, someone asked me how long I've been a survivor. I had to think about it. Am I a survivor as a metastatic cancer patient now? And while I did not have the answer that day, I quickly figured it out. Darn right, I'm a survivor. We are all survivors. We are all survivors until we are not. The second B, believe. Even though you think of it every hour of every day, every little thing reminds you that you're living with the disease. Like when I'm requested to sign a receipt and I have to use my own pen. I think of it when I have to open a door or shake someone's hand at church. This is because my white blood cell count is so low. You are also reminded when you're not thinking about it with all the metastatic breast cancer commercials come on the air. Believe and live life to the fullest. When I first learned it came back, I saw a necklace that I really liked and wanted to purchase it, but then I thought, how long am I going to be around to enjoy it? A few days later, I tried on an outfit that I liked, but I thought, how much time will I be around to wear it? Yes, no, maybe. Buy it if it makes you happy. This is not dress rehearsal. Cancer cannot strip me from being me. This is a life we were given, so live. The third B is be beautiful on the inside. It is so easy to curl up on the couch some days, but my advice to you is to seek energy in others. It gives me great pleasure to do at least one good deed for others every day. A simple thing like giving a $5 off coupon to a lady standing in line because she needed it more than me, or visiting a friend's mother in a nursing home because you can. Get up every day with the intention of giving to someone else. In summary, caregivers, though it's hard work, relish the and you will never forget. To all of you out there, being here today shows how much you care. And fellow warriors, don't ever give up. Too many people are counting on you, and always, always give more than you get. There is no one here today that wanted to join this club. It is very lonely. It is very isolating. Waiting in the hospital for your infusion, lab work, or treatment. Excited to be with all of you today. I feel this is the coming together of individuals going through similar experiences. I'm excited to learn, to share stories, to hope together, and especially to make new friends. Thank you very much.
But every time I get something new out of it, and I'm just so appreciative of you. Thank you. So Liz talked about how $250,000 from the money raised at the walk will go to support breast cancer research. Over Komen Atlanta's time, we've started an affiliate here in 1991. We've contributed over $10 million to breast cancer research just from Atlanta. And what we do is we pool our research dollars with affiliates from around the country and with Komen headquarters so that we can make the biggest, best, most impactful research investments we possibly can. And actually, that's what brought me to Komen. I was diagnosed with breast cancer 9 years ago, and there was a drug developed through Susan G. That's what brought me to Komen, is I wanted to make sure that we were investing in the best and the brightest and the most cutting-edge research so that every single person has everything they need to detect and survive this disease. And our next speaker is on the front lines, a Komen scholar, a Komen-funded researcher with a brain this large, who is here to talk to us today about his research and what he's doing specifically with metastatic breast cancer research. Do you need to? just going to get his slides up and ready for you while I introduce him. So Dr. Kang is a Warner Lambert Park Davis Professor of Molecular Biology at Princeton University. That's a lot to say. After completing his graduate study at Duke in 2000 and his postdoctoral training at the Memorial Sloan Kettering Cancer Center, Dr. Kang joined the faculty of Princeton in 2004. His research focuses on molecular mechanisms of breast cancer metastasis. He discovered new genes that promote breast cancer recurrence, metastasis, and resistance to chemotherapies. His research focuses on tumor-stromal interactions that mediate organ-specific metastasis of breast cancer to bone and other vital organs. Dr. Kang also studies epithelial mesenchymal transition, EMT, I hope I pronounced that correctly, a key step in metastatic progression to find new actionable targets. Through Dr. Kang's Komen Scholar Grant, his research is focused on blocking a sticky protein in blood vessels to prevent bone metastasis. We're in for a treat. Please welcome Dr. Kang.
Thank you, Katie. And I want to thank Komen Atlanta for inviting me to this wonderful event. And I want to thank Liz for giving us share your personal story with us and give us strength and inspiration for people like us to continue working hard to find new cures for metastatic breast cancer. So I'm going to here to also share you my own story too, and it's a story about my growth and my development as a scientist with the support of Komen. So I'm a living example of Komen's commitment to supporting young scientists, supporting breast cancer basic science research, and also especially the research on metastatic breast cancer. So I started my lab in 2004 at Princeton when I moved from Memorial Sloan Kettering to Princeton. And the first independent grant I ever received as an independent investigator is from Komen. And it started our research program on trying to find the genes that are associated with the aggressive behavior of breast cancer and how they metastasize. And that's part of the story I'm going to show you today. And then later on, we continue to receive funding continuously for the next 15 years. Some of the grants I'm showing you here in this slide, looking at the mechanism of bone metastasis of breast cancer. And I was also fortunate to be selected as awarded the AACR investigator in breast cancer research, and it's funded by Komen, and that is in 2014. And 2 years later, I was selected as a Komen Scholar, and also just this year renewed as a Komen Scholar. So I've been, as you can see, throughout my career as a budding young scientist to endowed chair professor at Princeton, I have been supported by Princeton throughout the way. And that's not all. Actually, many of the young scientists in my lab, as you can see in here, many of them also received Komen fellowship, postdoctoral fellowship. And that's also essential for their growth to be their own independent investigator as well. So all four of them are either already professors of their own or on their way to become professors. So this is expanding the brain power of the new generation of scientists who is going to continue this fight against metastatic breast cancer. So my lab is entirely focused on the study of metastasis of breast cancer, and that is because breast cancer is the most common female malignancy, not only in the United States, but also globally as well. So this is a global problem. When you look at this map of the world, it's showing the most prominent cancer, female cancer in each country. And you can see that almost the entire globe is covered with pink. This is the most common malignancy and the leading cause of death in all the countries in the world. But when you look at the reason for the mortality from breast cancer, it cannot escape the fact that 90% of breast cancer deaths is, and actually probably entirely in the case of breast cancer, almost all breast cancer deaths is because of metastasis of breast cancer. And even though that's the case, at the time when I started my lab in 2004, when we look at the funding from the NIH, there are very little amount of money actually put into the research of metastasis. So when you see here today that Komen is now dedicated nearly 90% of research funding in metastasis, that's really a sea change in terms of how we become fully dedicated to battling the main problem of cancer metastasis in breast cancer. So this is a investigative report by a cancer survivor, Clifton Leaf. In 2004, he published this article in Fortune magazine looking at why we are losing the war on cancer at the time. And the reason is that even though 90% of all cancer patients die from metastasis, there's very little research on that. So we try to change that, and my research program, when it started, is then dedicated entirely to looking at the problem of metastasis. Because when you look at how people die from breast cancer, this is looking at the so-called 5-year survival rate of breast cancer in the 70s up to 90s, and that trend actually has been continuing in the last 10, 15 years. For a patient diagnosed with early stage breast cancer, the 5-year survival rate is actually approaching nearly 100%. So it's very treatable. A lot of patients will have successful surgery, and but even for those patients, about 20 to 30% of them later on, 5, 10, 15 years later, will develop relapse, and some of them are metastatic relapse. So that is a problem. The bigger problem is for patients who have already diagnosed with late-stage breast cancer, stage 4, for example, they're already metastasized to distant organs. Their survival rate is 5-year survival rate is much lower, 20%, and that has not improved much in those 15 years that you're seeing here. So, thinking about that, how do we improve, reduce the deaths from breast cancer? One possibility is to develop more effective early detection methods. If we can catch breast cancer early on, maybe we can prevent them from getting into the stage of metastasis. But early detection may not be able to solve all of the problems. This is actually looking at the data tracking at the detection of metastatic cancer at the first time of diagnosis. Looking at prostate cancer and breast cancer or metastatic cancer at the time of first diagnosis. So when you look at prostate cancer, in the 90s, the PSA testing was introduced to try to detect prostate cancer early on. And as you expect, in the next 20 years, there's a steady 60% drop in the detection of metastatic breast cancer at the time of first diagnosis. So this suggests that indeed early diagnosis is actually effective in reducing, certain cancers from progressing to metastatic stage because they're detected early and taken care of. But in comparison, when you look at breast cancer, mammogram was introduced in the 80s, and that was very effective in detecting many of the early stage breast cancer and leads to improvement in the survival rate. But when you look at metastatic breast cancer at the time of first diagnosis, that actually did not change. A highly aggressive form of breast cancer that metastasized early, and it's not going to be, unless we come up with a better early detection methods, we are going to continue to encounter patients who didn't do anything wrong. They do everything, mammograms, everything, but they still have the disease at metastatic disease, stage at the time of first diagnosis. So that means that we still need to find ways to treat metastatic cancer. We cannot completely rely on early detection only. So the main goal of my lab has been in 2 areas. One is that can we find genetic markers, so-called metastasis genes that will allow us to provide a better prognosis or so-called crystal ball for the patients. And that is for those patients who are diagnosed with early stage breast cancer, they always have some risk of a relapse. Especially, we know that some patients will have same size of tumor, and they have same kind of surgery, same kind of chemo, but you could see one case that the patient essentially is cured, but on the other case, certain patients are in a higher risk, so that we need to treat them maybe more aggressively with adjuvant treatments, adjuvant therapy, chemo, and targeted therapy, and also follow them more closely. So the goal is to find so-called molecular crystal balls to identify patients in high risk and to treat them accordingly. What's more important is that if we are able to do that, imagine if a patient come into the hospital, and we look at her tumor, and we said that, well, this is a poor prognosis tumor. It has a high risk of relapse and metastasis. Is that the only thing we can tell the patients? Or we can tell that, well, we know the reason why your tumor is such a high risk, but we have a treatment to prevent that from happening. That will bind the really aggressive tumors, but also try to figure out why they are so aggressive. And then the next step is to find treatments, therapies to prevent them from spreading, or if it already spread, more effective treatments to treat those disease at a metastatic stage. So that has been the overarching goal of the research program in my lab. And the first grant that we received from Komen essentially support this goal, is to find the markers that identify highly aggressive tumors and try to treat them. So this led to the first publication 4 years later. This is a publication in Cancer Cell showing the identification of key genes that drive chemoresistance and metastasis of breast cancer. That's why it's represented with this double-headed snake in the cover of the journal. So the idea started with looking at the genomic data that the clinicians and scientists have been looking at in the patients. And you probably heard about this, something called MemorPrint. So this is the technology that's actually available in a hospital now that give the patients a digital reading of their gene expression profile of the tumors and give a numerical score of their relative risk of relapse and recurrence. So this technology is based on a landmark paper published in 2002, right around the time that I started my lab, by a group of scientists in Netherlands, in which they essentially use so-called machine learning technology to ask the machine to develop a biomarker that distinguishes highly aggressive tumors, like tumors here, versus not so aggressive tumors that are easily curable. So what you're looking at here are each column represents one single gene. So you're looking at 70 columns. And so this is a molecular marker of 70 genes. Each row represents each tumor from individual patients. And they are divided into two groups, the so-called good prognosis tumor on the top. Those are less aggressive, curable, and the poor prognosis tumors. They are likely to recur, likely to relapse, and likely to become resistant to treatments. So these are same stage of tumor, same kind of size. They look similar, but they clearly have different biological behavior in the patients. And you can see the machine identify these 70 genes that have completely opposite expression level. In red represent high, green represent low. And they flip their expression between not so aggressive tumors and highly aggressive tumors. So this is essentially the so-called molecular crystal ball. And this has been applied in the clinic to tell us whether a tumor is a high-risk tumor versus a low-risk tumor. But as I said, this only tells half of the story. We can tell the patient this is a high-risk tumor, but we actually cannot tell them why this is such a high-risk tumor. In science, in oncology, we are especially interested in the so-called driver genes that drive the aggressiveness or the growth of certain class of cancers. So at the time, what we set out to do is to try to find the driver genes behind these aggressive tumors that you see in here. So how do we do that? When you look at the history of driver gene discovery in different cancers, you can actually learn a few lessons from there. There's a common thing in those discoveries. And I'm using two cancer as an example. The first one is so-called chronic myelogenous leukemia. This is one of leukemia that is often associated with old people, and they are almost always affected by a strange genomic chromosome alteration that repeatedly occur in almost every one of those CML patients. It's the so-called Philadelphia chromosome because it's first discovered by scientists in University of Pennsylvania. And it's a chimeric chromosome created by, and essentially what happened is the tip of these two chromosomes, the DNA swap place with each other. And that essentially create a fusion gene called BCR-ABL. These two genes are originally located in two different chromosomes, but because of swapping, you fuse them together. And that becomes a monster. It becomes the driver gene that drives the aggressive growth of those CML tumor cells. And because of this discovery made in the 1960s, that eventually led to the development of a drug that was approved in the late 90s and early 2000s called Gleevec, that essentially turned this lethal disease into a chronic situation. As long as the patient take the drug, they live for a long time. Another example that you're probably more familiar with is HER2. HER2 is amplified in about 20% to 30% of breast cancer patients, and that identify a class of breast cancer called a HER2-positive breast cancer. This is a highly aggressive subtype of breast cancer because it's driven by this gene called HER2. And HER2 is become hyperactive because it's amplified to dozens of times, 20, 30 times, compared to only 2 copies that we see in this gene in our genome. And the red dots that you see, each dot represents each copy of HER2. And you can see there are many, many dots here. And that drives the aggressive growth of HER2-positive breast cancer. And that eventually leads to the development of Herceptin that effectively control many of the HER2-positive breast cancer. So the lesson here is that when you or amplification, that shows the landmark, the location of the driver oncogene. What we try to do here is a little bit different. We try to find the driver genes that drive the aggressive behavior of cancer cell compared to the less aggressive tumors. And this is harder to do because you are comparing tumor with tumor, and they are total mass in each case. You are comparing mass with mass. Compared to here, you are trying to compare tumor with normal cell that is in good order. So that leads to the development of a computational technology that we developed at Princeton. I'm not going to go through the math here, so don't worry about it. So what we're essentially doing here is using a mathematical conversion to convert one type of information that we gather from patients, which is the so-called mRNA level of there are 20,000 genes gain or genomic loss. Copy number gain, copy number loss. And that is shown by the red peak on the top or the green peak at the bottom. And that will give us essentially a roadmap to find a spot that likely harbor the driver genes of aggressive tumors. So essentially, what you're trying to do is set out to find goals that find the genes that associate with cancer aggressiveness and metastasis and to try to target them. But you need a roadmap. You need to find where to dig. And this computational program will give you the location of where to dig in a chromosome. So this is what we did, and this is done by Go-Hong Hu, who is also a Komen fellow and now is a full professor associate director of a cancer institute. So he used this algorithm and analyzed thousands of patients in Europe and in the US, and he finds something in common in all those thousands of patients. No matter where you look, there's always this location in chromosome 8, the long arm Q, location 22. So this is like Atlanta and Georgia Tech Hotel. This is the location that marks the location of the gene that could be driving aggressiveness of the tumors. And so using this as a landmark, this is looking at the real tumors of patients treated at New Jersey, Cancer Institute, New Jersey. And here, the orange dots represent the gene that we are looking at, so-called MTDH, the culprit of aggressiveness that we try to identify. And you can see in some of the tumors, you don't see just 2 copies that you should expect. You see 6, 7, more than 10 copies of those genes. And so those are representing tumors that have amplification of MTDH versus tumors that only have 2 copies and they do not have amplification of MTDH. And so now it's the test to see if this marks those aggressive tumors. So when you look at the patients who have amplification of MTDH versus no amplification of MTDH, and you track how long they survive, how long they stay alive, 5, 10, 15 years after diagnosis and treatment, you can see that the patients who have high copy of MTDH, within 5 to 10 years, about 40% of them already die from breast cancer. If they have low copy of MTDH, almost all of them still surviving after 15 years. So this is a clear way to show that indeed this gene, he published this finding back in 2009, that was 10 years ago, and it made major breakthrough in the field because we find a gene that very few people know before. At the time we published it, there are only a total of 6 papers in the whole entire universe. And so there's very little understanding about it, but clearly now we link it to the aggressive breast cancer. But at the time, we still have no idea how it works. Is it essential for our own living, normal cell behavior? And is it a suitable drug target for drug development? So at the time, a graduate student in the lab, at the time she just started, and now she's starting her own independent position as a faculty assistant professor at University of Pennsylvania. So you can see how fast young people, they look like kids, and you turn around, they are professors, you know. So Li-Ling at the time decided to use genetics in mice to show, you know, to try to figure out whether this gene will be suitable for drug development. So what she did is using this so-called knockout technology. So it's a technology we can knock out a particular gene specifically without touching other gene in the mouse. And we essentially wipe it out, in the mice. If it's important, die in embryo or die early. But here you can see this is the mouse without MTDH. It's a knockout mouse. And the mouse still looks like a mouse. It doesn't look like a rabbit or something else. So this gene, loss of this gene doesn't change anything. You know, the mice still develop normally. But the mice we use here is not regular mice. These are genetically engineered to be prone to develop breast cancer. They will develop cancer about 4 months after birth. And they will develop metastasis to lung, and eventually they die from lung metastasis. So in a regular mouse, they have all the genes intact. At 6 months old, they will develop multiple tumors. Mice have 5 pairs of mammary glands. So this mouse looks fat. That's because it has multiple tumors in the mammary gland. And it also develops multiple metastases you can see in here, in the lungs. And eventually mice die from metastatic breast cancer. The same mouse here is carrying very little tumors. And even if they grow those tumors, they grow very slowly here, compared to the wild-type mice that grow exponentially. And they almost never metastasize to lung. So this is the genetic evidence to show the pharmaceutical companies love to see this kind of data, because it shows that if you try to treat patients with a drug that try to target, suppress this gene, it's unlikely to cause side effects, because you could just wipe it out and the mice still will be alive. But it's essential for the tumor to form and to metastasize. So this is the ideal drug target. Very little side effect and highly important for tumors. So, Li-Ling, this is the work she did, and she graduated. The next big question then is, well, we know it's important and it's potentially a good therapeutic target, but how do you target it? You know, you need to have a way to suppress the function of this protein. We cannot knock out this gene in humans, at least for now. We still can't do that. So what Andrea did here, and he's also now an assistant professor at UPenn. So you can see they all graduate and they all go to Penn to become faculty member. So what Andrea, what he did is, in a cell that have MTDH, this band in here represent MTDH, he was able to pull it down using biochemical methods. And it's just like when you go fishing, you have a bait, and then if the fish bites, you pull out the fish. That's how you go fishing. He used the MTDH as a bait to see what protein also interact with it, because this is how our proteins work in our cell. They don't work alone; they interact. And that's how they carry out functions, including functions that drive aggressiveness of cancer. So he used MTDH as a bait and pull out another protein called SND1, which turned out to be really important for cancer as well. And why is it important? In a normal cell, it doesn't really matter that much because the cell grow happily. They are not under a lot of stress. When we have insults from radiation, from harmful chemicals, it causes transformation of normal cell to become cancer cells. So it's a process called oncogenic transformation. But it's a highly stressful process for cells. When the cell under oncogenic transformation, they are under a lot of oncogenic stress, and they actually try to kill themselves doing that. So to keep them alive, SND1 is important. But under stress situation, SND1 becomes unstable. So by binding to MTDH, SND1 becomes stabilized. And that allows so-called cancer stem cell or tumor-initiating cell to survive under that stress. And that will see the development of the primary tumor and also the metastasis. And this is why both proteins are so important for breast cancer, both for formation and for metastasis. So when you knock out NTDH, or when you have a drug that blocks its function or its interaction with SND1, it makes SND1 become unstable under stress. And cancer stem cell would die in those stressful situations, and then you never have tumor growth or metastasis. This is how it works. So the idea now is, can we block the interaction between these two proteins as a way to drug this interaction? And that requires knowledge from another discipline of science, which is called structural biology. So structural biology is looking at the protein in a very, very microscopic way. The green protein is this protein called SND1, which is essential for the survival of cancer cell. The yellow part is just a piece of MTDH that is holding on to SND1 and stabilize it. And you can see that this interaction depends on a lock and key interaction. So you can see in the surface of SND1 in cyan color here, in the top and in the bottom, there are two little caves that you can see, two little cavities that you can see in there. And that was inserted by two amino acids called tryptophan, which are like two fingers that stick into those two caves. And this allows these two proteins to lock into each other and hold on to each other. So to make it even easier to understand, it's like, imagine you go bowling. How do you hold on to the bowling ball? Use your fingers to stick into the holes, and that allows you to hold tight to your bowling ball and you can swing it. So if you are a pharmaceutical drug company executive, you have an idea to develop a drug. How do you prevent MTDH? Imagine that as your hand to hold on to SND1 as the bowling ball. You could stick something into the hole of the bowling ball, and there's no way you can hold on to the bowling ball anymore. And this is what we try to do, is find small molecule compounds that stick to those holes precisely, and they become the therapeutic drugs. So this is what we did in the lab and done by another post. Essentially what we did is we developed an assay that allow us to screen millions of compounds. Some of them are natural compounds, some of them are synthesized. And essentially find a compound called C26A6. It's a very boring name, but that's not the important part. This compound is actually stick to that holes that I just showed you. So now is the exciting part. We now test it to see. This is a project that now is carried on by Min Hong, and he's a Komen scholar, a Komen fellow. So it's supported by a Komen postdoctoral fellowship to test this compound to see if it's actually working. To start with vehicle, the other group treated with this C26A6 compound. You can see, measuring the tumor, you can see the mice treated with this compound grow much slower. The most important one is when you look at lung metastasis, the mice treated with the compound have a lot less, almost tenfold less lung metastasis compared to the mice that are treated with vehicle. So this shows that indeed we eventually find a compound that could potentially further develop as a therapeutic agent, a complete new compound, first in the class, to treat or prevent the development of metastasis. So I use this as an example to show the journey it took from a basic science discovery in the laboratory is important, because we get our inspiration of basic science research from knowing what matters to the patients. And the question here is, for patients who have the same kind of tumor, why some of the tumors are aggressive, some of them are not. The outcome is very different. And that inspires us to use computational biology to find location that could harbor those driver genes, and eventually identify this one single gene called MTDH. And then we use mouse genetics to validate it's a suitable drug target. It's important for cancer development, but not essential for normal physiology. And then use a lot of pathology, cell biology to figure out its function. And then use a different discipline, biochemistry and structural biology, to figure out how they interact. And eventually use drug development to develop a new compound that eventually go back to benefit the patients. So this is one example. And another example that I want to quickly go through is also another study funded by Komen, which is looking at one of the major complications of metastatic breast cancer, which is bone metastasis, which affect 70% of late-stage cancer patients. And this is a work in collaboration with a company called Amgen, which is one of the supporters of this event as well. So we know patients suffer greatly from having having bone metastasis. They have pain, they have fracture, and they have hypocalcemia. But it's also important to know that actually the cancer cell is not able to break the bone. It's not because cancer go to bone and chew out the bone. They are not able to do that. When you look at a bone metastasis, this is a mouse bone metastasis generated by human tumors. In the interface between the tumor and the bone tissue, you can see those large giant cells. Those are not tumor cells. Those are osteoclasts, the bone resolving cell. And we have those cells in our body, all of us. It's important to resolve the old bone and build a new bone because that keeps the strength of our bone tissue. But what happens in cancer metastasis in bone is the tumor encourages hyperactivity of osteoclasts, and that breaks the bone to drive the aggressive growth of the tumor cell. So there's this concept so-called seed and soil interaction in metastasis. The cancer cells are seeds, and they only grow in suitable soils. And one way of therapeutic development is actually not thinking about how do you get rid of the weeds, but actually try to treat the soil to prevent that becoming a seed and soil interaction. In the case of bone metastasis, the bone is degraded by the osteoclasts recruited by tumors, and they release growth factors like TGF-beta, which is highly abundant in bone. TGF-beta then signal to tumors to activate signaling pathway that induce the expression of a gene called JAG1. JAG1 is expressed in the surface of cancer cell, and that becomes like a hand. It allows the tumor cell to shake hands with the bone cells, and that leads to the growth of bone metastasis. So in the case of the bone-building osteoblasts, that JAG1 not signaling stimulate the osteoclasts, produce growth factors that feedback to promote tumor growth. In the case of osteoclasts, JAG1 stimulates osteoclasts to become hyperactive, and that release more osteoclasts to break down the bone. So this is a so-called vicious cycle. It drives itself. And because of that, we collaborate with Amgen, and we developed a human antibody called JAG1. The first group is mice not treated with anything. The second group is the mice treated with standard chemotherapy, Taxol. And you can see initially in orange, the tumor responds well. You have slowed down growth, but they become resistant to treatments. And in the end, they grow almost as fast. So this is typically what we see often in the metastatic cancer patients, that their tumors become resistant to chemotherapy, standard of care. So now what we are doing here is we then apply the antibody that we just developed. In red is the mice treated with the antibody. And you can see there is a significant slowdown. It's a tenfold slowdown because this is in log scale. So each notch is tenfold. So it's showing promise. But the most exciting result is when you combine chemo with this antibody, you see in green 2 log difference. That means 100-fold difference. And in the mice, you can see untreated mice, single treatment in the second and third group. In the last group, is almost free of bone metastasis. So this is working really dramatically well. And we are actually wondering about why there's such a strong synergy between these two kinds of drugs, chemotherapy and the antibody. And to keep the long story short, the story is that in the bone marrow of the mice and also in the patients, when you look at JAG1, it has very little expression without chemo. After chemo, JAG1, this happens in the mice, but also in the patients. This is in patients as well. So what happens is those osteoblasts, when they have high level JAG1, they become cradles of protection for tumors. They are under the attack of chemo, and they protect them from chemo-induced cell death. So with the antibody, we eliminate that side effect. We make those cancer bone metastases much more susceptible to chemotherapy attacks. That's why you see this such a strong synergy. So this is the final data slides I want to show you. So what we try to think about here is if this antibody is such an effective way to enhance the efficacy of chemo, can we try to modify adjuvant chemotherapy that we are trying to apply to the patients nowadays who have early stage breast cancer to prevent the occurrence of metastatic cancer later? And we know it's useful in treating patients who already have metastatic bone disease, as I show you here. Here is a test. We have a group of mice that have breast tumor, and then we treat them either with chemo or with the antibody or with a combined treatment. And then a few weeks later, a few months later, we follow up to look at their bones to see if they have bone metastasis. So you can see without any treatment, about 55% of mice would develop bone metastasis. With single treatment of antibody, about 50%. Single treatment of chemo, about 35%. But with a combined treatment, only about 10% of mice develop bone metastasis. So the bottom line of this study is that with this study, we show that there's complications with chemotherapy. So chemotherapy is achieving great undesirable side effect, which is in changing the soil in the bone to actually make it more hospitable or protected for the tumors that are already there. And what we try to do is developing this antibody to remove this protective shield induced by chemotherapy and make the chemotherapy much more effective. And so, so this is the finding that we did in the lab. Actually, when we published this work, but there are also other papers published in the field showing some of the undesirable side effects of chemo in actually driving aggressive behavior of cancer cells, and actually, as you expect, induce some of the fears in the patients, because some of them are receiving chemotherapy and you don't want any of these side effects. So I'm actually, at the time, I was the president of the Metastatic Research Society. So we decided to put up a commentary to address this concern. Essentially, what we try to say, basic science study is actually giving us new insights about what we could do further to improve the efficacy of chemo. But it does not really say that you should skip chemotherapy. Instead, that's probably not the case. The patients should talk to their care providers, their physicians, to see, address their concerns. But in most cases, the patients will benefit from chemotherapy. What we try to do is develop a therapeutic agent that make the chemo even more effective and even safer in the patients. So I want to also end by saying that my collaboration with Komen does not really end just laboratory research in my lab. It's in a broader scheme of things too. As the president of Metastatic Research Society, I have expanded the collaboration of the society, which include researchers in a global scale with Komen. So last year, the society had biannual congress every 2 years in global locations. And last year, because I was the president of the society, we have our biannual meeting at Princeton. And this is kind of weird because Princeton doesn't have a medical school. But you have this, it achieved two main goals of the conference. One is to expand this patient advocacy session at a meeting. And this is one of the photos I took, in which we create a forum to allow the patient advocates to have interaction with scientists. And also, this is video stream in the online platform to reach a broader audience. So this is our effort to build a closer connection, because patients inspire us to do the most relevant research in science. And we also want to communicate our science in the best way to the patients as well. Another important thing Komen help us do is to expand the support for the young scientists. So Komen provide travel awards to bring patients, but also young scientists, some of the award recipients, to come to the conference. Because 15 years, and we have trained almost 60 to 70 students, graduate students, postdocs, and undergrad students. And almost all the undergrad students become doctors. Some of them will be treating breast cancer. And more than 10 people already become professors of their own in the US, in China, in Europe as well. So this is one of the ways that we try to reach the bold goal of Komen to end the death from breast cancer, is to continue to support cutting-edge research and also continue to support the development of young scientists, because this is how we keep this winning battle instead of a losing battle against metastatic breast cancer. So thank you, and I will be happy to take questions.
I noticed that your SND1 inhibitor research was targeted to lung cancer. Are you making a leap to breast cancer with that same inhibitor?
No, actually, probably it's not clear. Those are all in breast cancer. It's looking at lung metastasis of breast
lung
cancer.
metastasis.
Yes.
Okay.
Yeah.
I realize that you're more on the preclinical side of things. Have any of your discoveries moved into clinical trials with patients?
Right. So, and some earlier compounds are still in the IND stage, so we still need to go to phase 1 first. Yeah. Thank you.
Thank you, Dr. Kang. We're going to have a short 10-minute break and then come back for our community tumor board. We're trying to make up a little bit of time here, so we will start promptly in 10 minutes. Thanks, guys.